Welcome to Tutorial 4, a basic review of your inputs and outputs in C++. Now, the original tutorial doesn't come with any code, but I have created some, and you can find it in the users/library comp1633 tutorial/tutorial4_IO. You can copy that to your directory using cp/-r, giving whatever path here, and then dot. I'm just copying it to the current directory. But I've already got it here, so I won't run that. You can see I've got it right here, tutorial4.io. In here I've got a couple files. Basically I've set up a make file that does multiple compilations and brings everything together, so you can manually go through the document to see what your memory is, and then you can also, your memory, you refresh yourself on your skills, and then you can come back and run the questions themselves. So you've got the main file here, you've got an IO utility file that will be used in future assignments, and then you've got the actual individual questions created into individual functions that are called. You also have any test text files in the test files directory, and you have a make file right here. I've got everything set up that I will keep multiple windows open. I'm gonna have the lab here. I'm going to use these two windows right here to show some code, and I'll use this window then to compile and run everything. Okay, so to start with, you can open the make file if you would like. This again is like the previous labs where we did separate compilation and make files and setting that up. It does all of that and then adds a little bit extra to it. So you can see your variables for your make files. You can see your rule right here, which I use to compile and clear the screen and run, just to compile, to clean, and do everything else. But what you're going to see is some extra rules that normally you would have had to add rules at the bottom for every single file you want to do to actually compile to get your .os. This is one way instead that you can just list all the source files that you want to compile. This rule then stays exactly the same, say taking all your sources, and it says using a rule of .cpp to .o files, which then when you're using modules anywhere, it will then kick in if there's not a .o file for your .cpp file, it'll use this rule. So again, this one right here, so then is just listing all the sources you want to be compiled to create your actual program itself. Right here, this makes your modules, replacing that it needs the actual .os that you have. And then anywhere you see that it needs modules, if there isn't a .o for it, it'll end up calling this command here to do the compilations. And so this one right here is that when this rule is kicked in, this is the file that it's actually being given. So it's one way that you can create one generic make file to do all of your work. If you want to just compile everything for the code, you can just run make check. Otherwise, just to make this tutorial go faster, is every time I make a change, I'm just having it clean up my old code, recompile everything, clear the terminal window, and then run the program just to make sure that everything looks nice and convenient for these tutorials. And also showing that in make files how you can throw in other commands that you want to use. Okay. If you look at toot questions, toot4 questions.h, you can see that you've got your preprocessor commands to make sure that this header file does not get included multiple times, and you have the prototype for all functions that are here, so helper functions that I'm using, and then the individual questions broken down into functions themselves. And if we go to the .cpp, you can see then everything else then laid out in here and all the individual questions that I'll be going through in a second. And in the main right now, It just includes our two questions, and it has question 1 uncommented, and it'll just run that one, and then the idea is just comment out the questions that you don't want to run and uncomment the one you do want to run. And you'll see me doing this continuously throughout. So in this top window, I am just going to keep the main open so I can do work with it. And in this bottom window, I'm going to open up .cpp file so you can see some of the code that I have in there. So we got question 1. So again, this tutorial is just going to be a quick run through to give you a refresher on your inputting of characters and the actual differences. And the file I have open here is actually the solution file that will be posted with the tutorials as well. So the first question is, assume that ch is a character variable. What is the differences between these two calls of the cin like you've regularly done or just cin.get? Now the biggest thing right here is that the cin.ch reads the first non-white space character. So white space being spaces or tabs. So if there's spaces and tabs first, it will skip over those and then read in a character. Whereas cin.get doesn't care about white space, it's just whatever is the next character on the actual input, it will actually read that in and store it. So in the code itself for right here, I've got it outputting saying what question right here, and then saying, okay, enter the first character, and just doing a regular cin, and then enter another character right here, and then outputting it. So we can make sure for what we're getting. To compile and run all of this right now is either you can do make check right here, which is just to see if there's any errors and just shows the compilation. We've got our .o's, and then we've got the toot4 file here, which is the name of our actual executable. Or you can just hit make and it will clean out any old files, it'll recompile it, clear the console, and run the program. So you can see here, came back, ran the program, console's all clear, we're ready to enter the actual first character. So since this is the regular cin, if I add in some spaces and maybe like hit the tab character like this, and then I can put what character I want right here, it's going to read in that first character here. You can see that we're getting, what's the first character? Right here. There's. Now one thing about this with the actual G right here is that the difference also is that cin.get doesn't wait and doesn't need an enter, it just reads a character in if it's on the actual input stream. So we entered some tab spaces F and the G, so the first cin gobbled all of this up and then read in the F and put that in character 1, and then G was left on the input stream. And so then automatically cin.getRead just read in the actual G right here. And so this is why we're not even seeing the new line after. We're getting this F, we're getting this G, and right here. And one issue is that because we use cin.get but hit enter, after this last one, is that that /n is still sitting on the actual input buffer. So let's run that again. Right here. So if I just do some spaces and this time just do one character and hit enter, we can see we go down here and we can still see like, oh, well look, it seems like this is blank, it didn't even wait, as though this time again, read in the actual F, so the extra space is F, but right after this I hit enter, which is an actual character, and that was read in as the actual second character there. Okay, so we go to question 2. Now this is a different one here, is assuming that we have an integer variable called I, double variable called D, and a character called C, what will happen for these actual outputs? And remember that it's in the order that it's going to read it in this first, then this in the actual order, and it reads it in based upon the type of the actual variable we have here. So you can see this first one is if we are reading in 97 to 10.5. Now the first thing is saying that C, which is a character, and so it'll just read in just the 9. It won't treat it as an integer, it'll just treat it as the character 9. What's left after that on the input stream is all of this. So there's no leading spaces or anything else. We've got this one character right here that's been read in. Here, next it's going to be reading an integer, and it's going to read any white spaces, then any numbers, then stop when it hits a white space. So it's going to stop right there, and it should just get a 7. Then after that we have the actual double. So that will then read in, okay, there's spaces, so I'll get rid of those. Reads in the 2, stores that as a double, and then right now the rest of this would be left on the input stream. And so it's a similar thing for the rest of them. So you can see this if we go now, change our program. So I'm going to go to main, comment out question 1, uncomment question 2, and save that file. Come down here and you can see then question 2 that I've got a reproduction of all the code here. So we have these 3 right here, and we can go through entering the actual inputs we got right here. So we enter the first one, should be 97 space 2 space 10.5. And you can see there we got, as we expected, that 9, then the 7, then the 2. The next one after this is going an integer, then a character, then the double. So integers will read everything up to a non-digit number. So it'll read the 123. The dot here would be considered to be another character, so not do anything else. So then it'll stop reading this. The next thing we're reading is a character, so it reads in the actual dot and then stops when it hits, it's only asking for 1 character. And then the double will read in the 45. So we can test that again, 123.45. There you go. And then the last one is then reading in a double, then a C character, and then the integer. And this one's expecting some spaces on the input. So again, for the first D, it'll gobble up these and not use them. Then it'll read the 12. See that there's a decimal place and keep reading characters, so it'll read in the 12.0. We do then reading a character for right here. That here is just doing not a cin.get, but right here, which will then, the regular cin, which will gobble up any white space, so get rid of this. It'll then read the minus sign right here, save it here, and then it'll stop, and then the integer will read in the 12. So we'll go test that. 2 spaces, 12.0 space negative 12.0. There we go, 12-12. Okay, that's what you should expect. So that's your little review of the difference of using the .get for characters for CN versus using regular CN, and the order then to read, and how you then can start doing some parsing of input on your streams. So question 3 is, consider the following declarations. So we have a constant saying max name size 50. Then we have a character array that's 50 plus 1. We're supposed to write 1 line of C++ code to read a user's full name given, so their given name and first name, up to 50 characters long. So the important thing here is we want to have 50 characters right here. This plus 1 is so our buffer has 1 extra character for the null marker, which you need to have, which marks the end of actual strings. And here, one solution for this is actually either to use the cin.get line, where you give it the buffer and then the actual space, so how many spots there are in that array. And this will read everything with the default up till a /n. Or you have the cin.get here, which will read everything up until this, where you're specifying what character to keep reading up till. So if we go back to our test program here, you can go to the main, comment out question 2, uncomment question 3, and we'll go to the .cpp file, and you can see it here. I'm telling them to enter it. I'm using the get line with full name and then the actual buffer, and then outputting what string was right here. Now note, this, if they type more than these characters, won't gobble up extra ones. It'll just read in up to a max of the max name, whatever size that's been set to. So let's go and run it. Okay. Put in my name. Magic! So that's your step of how to read basic strings, but with no actual error handling. On to the glorious task 4, or question 4. So this one has a whole bunch of different inputs to show the variations of what you're reading, what you expect, and being very careful that you know what's on the input stream. Because you have to remember when you're reading characters, what's going to be the next thing that's left on that stream once you've eaten up, because the stream of characters and inputs that are coming into you. And so you've got to remember to be careful that what are you reading, what are you leaving on the input stream, so that the rest of your program will function properly. So we'll assume that we have a character array of size 8 at the top, and then just one individual character. And now we're supposed to do each of these actual outputs and then say, well, what will you see on, what will str contain, what will the character contain, and then what will be left on the input stream. And the little arrow that you're seeing here is representing if you'd hit enter. And you can see the actual input here is the little marker under here is just supposed to say that we have a space in between. So to test all of these, to match up to see what we're getting here, I'm going to again go to the main, comment out question 3, uncomment question 4, and I'm going to go to the code. Now to do this code, I didn't want to copy and paste a bunch of times, so I just have a loop that goes through each part and a switch statement to switch up how it's reading the actual inputs. And then to make sure that when I go to the next test, there's nothing extra weird on here, I am just using the cin right here, is assuming that you don't type more than 100 characters. It's just going to try to empty out what's left on the input stream before we go to the actual next output and output here. So we can step through and then manually test each of these actual inputs to see what we're getting. So what we should know so far is, okay, we're doing a regular cin, so this will skip leading white space that comes in the actual beginning and read up and stop till it hits a white space, and then this will read in one character, skipping over leading spaces as well. So let's go through now remaking the program. We'll do the first input now. That should be for testing part A. You can see right there is then A, B, C, D space E. And matching up here, yep, we can see that str read everything here in the beginning up to the actual space. And then when we went to read the character, it gobbled up leading white space and then read in the E, then stopped, and left on the actual buffer, you can't visually see there, is this actual new line. Okay. Now on to B. This one's different because this one again now is doing the normal cin, but now we're doing a cin.get. So this will not read in any extra white space. It'll just read in whatever character follows after was left on the input stream for this. So this first part will read in the A, B, C, D, and then this will read in the space, and then the E will be left on the input stream. On to part C. So this one is cin.get here, str, and then 8. So this will read in 8 characters and then stop for right now, and then the actual cin right here for the next character. So this, if there is less than 8 characters, when it hits enter, will just actually stop for the actual input. So here we have 1, 2, 3, 4, 5, 6. And so it's going to read in all of these and that new line and then like stop. And so it's going to gobble all of this up because the new line is a default delimiter, so it'll stop. And then you'll have this in the actual first string right here. And then this here will be nothing on the input stream, so it'll be sitting there waiting for more input to actually come in. So you've got to enter a character or hit enter. So we'll go here. Now you can see nothing else is happening here, so this is where it's waiting for that next character to actually be entered. And there we go. You can see how it read in everything up to there, right here. So again, this will try to read up to a maximum of 8 characters. If there's less, it'll stop. If there's more, it'll only read in those actual 8 characters. So this here, and like this will then read in any white space. So this next one for D is the same thing. So reading the 8 characters, but then this will just read in anything that you had that's sitting on that input stream. So in this case, if we run it with A, B, C, D space E and hit enter, right here, it's still waiting for some kind of actual input. So similar thing to the previous one. This next one right here is different, is that instead of using the default delimiter, which you would have had from the get, which is the new line character, /n, here this then specifies the new delimiter to be a space. So it will read up to 8 characters at most, but it will stop early if it hits a space character or there's nothing else on the actual input stream. And then this will read in anything that's left after other white space. So this will read in this first part here, not reading in the actual space, and then this right here will read in everything else, so skipping over the white space and then storing the E into that character, and you'll be leaving with the new line still sitting on the actual input. So there you go. You got ABC, you got E, and then not visually shown here is that new line. Okay, go on to F. Similar thing here. But now here's the difference, is that we're using the actual .get. So this time the leading white space will not be removed. So this first line right here will read the A, B, C, D, stop at the space leaving on the input stream. So then the cin.get will actually read this actual space, and then the E in the new line will be left on the input buffer. And there you go. ABC, that's got the actual space, and on the input buffer you've got the E in the actual new line. Almost getting through these. So same thing, you specifying your delimiter up to the /n, but this will only read the max of 8 characters, remembering from right here, or stopping when it gets to the new line, and then this will read 1 character here. So if we do a longer one right here, I'm not going to do A, B to Z from right here to the point to right here because you get the point here. I'm just going to do it numbers so it's easier to see what you're actually getting. So you should get the first output of the first 8 characters, then the 9. So in this test, instead of me typing out all 26 letters of the alphabet, I don't think anyone wants to watch me do that. I will just do 1, 2, 3, 4, 5, 6, 7, 8, 9 right here, and then A, B, C, D, E, F. And so what we should get is the first 8 characters here will be read in because that's what we specified the input size, and then it's going to stop. Then the cin.get's going to read the 9 in as a character, and then the rest of this is going to be on the input buffer. And there you go. So the 1 up to here. So the 1 up to the actual 7 right here, so it reads up to 1 then less than that because we only have 8 that it's expecting in the new line, and then the 1, 2, 3, 4, 5, 6, 7. So even I got that wrong quickly. Remember, so the 8 will read in the first 7 characters and then not read in the next because it needs to read here, up to here, and then read the rest. Okay. We are on to H. So this one will then do the same thing but delimiters with an actual space in the actual character. So ABC. So similar to one that we had before, but the get line, these were doing the gets, but this does the entire get line. So get line in this case will consume the actual delimiter versus when we were using the get before. So in this case, the input will be different, that it goes A, B, C, D, E, consumes this, so this is here, consumes the actual space you had coming afterwards, because that was our delimiter that we had there, and then has the E follow afterwards. So that's why we got that as our output there. For I, this is doing a get line again for right here. And the way that this one switches it up, this is for doing a new line. So it'll read everything up till it gets to the new line, read the new line. And then this will stall for input till something is actually entered. So you can see it's stalling and waiting there. And there we go. That entire line up to the new line, then F, and then nothing on the actual input buffer. Now finally for J, right here we've got cin.getLine, character 8, what we had before and consuming it, and then the cin.getH. We do our input once again of being numbers. You can see here that it read everything up to those first 7 characters, and then we have space left for the marker. And then, but in this case, you can see here, and then we have issues that there's no read possible, input stream is in fail state, C part G. So we have these input right here, so it read all the rest of these, but you can see it's kind of screwing up right here, that we had the actual 8, and then the F coming out here. Okay. Question 5 is a review of doing some file inputs now for streams. So you can see the solutions here, and I've got it in the code as well. So before I mix anything up, I will uncomment comment out question 4 from the main, uncomment question 5, save the file, and then we'll just move down below here to question 5. So it contains all the code that you see here. And so it's assumed that you have a file called numbers. In here, I've got all the test files under this directory called test files. And you can see in the file called numbers, I've just got these numbers in here so far. So this is supposed to be, assume that you have a file called numbers, contains a sequence of doubles separated by white spaces. You're supposed to write a short program to compute their average and write it to the output stream. So the idea here, as you expect, is that we're supposed to loop through it. So we have to, 1, open the file properly, 2, read through the file until we get to the end of file, so your EOF, and then read in each individual character right here. And we know that they're separated by white spaces, so it'd be a good idea to do a normal cins from right here. Or not a cin, our normal like inputs, but doing with the file stream instead of the console input. And so we have each of these numbers we're supposed to step through one by one until we get to the actual end. So we're going to need a loop. Within the actual solution here, you can see you got your variables to keep track of everything, to sum everything up, because to get the average, the idea is you just sum it all up and you divide by the numbers you're trying to average. So we need to keep track of the sum and keep track of how many numbers we have, then a variable for the actual average. We have an input file stream we're creating here. We are opening it here for numbers. In my solution, I just have the file name then set to in the test files directory instead, but we open it. If we are unable to open the actual file, output a message, and then the idea is then we won't go into the else, so we'll just exit out of the program. Otherwise, we're going to the else and going through reading in the characters one by one. So we read in the first one, just assuming maybe if this is a blank empty file, so we've consumed anything that's in here, and doing a leading one that'll eat up any white spaces and try to actually read in a number. And if there's nothing there, we'll go into the fail state. And so then this will be a marker knowing, oh, it's read in, and it'll know that it's at the end of actual file. So here next is that while we're not at the end of the file, notice in the right up here, this is a small error. This should be fin, not fnp. So in my solution for actually running the code, I have that fixed here properly. And then I have it outputting the actual numbers just so you can see it visually as well. So otherwise, takes this one, checks to make sure we're not at the end of file. And then if we're not at the end of file, then it adds it, increments the numbers we've seen, then goes to read in another number, goes back up and checks once again, are we at the end of file or not? Once it goes through all of this, as long as there's been at least one number actually counted from right here to make sure that we're not getting a divide by 0, it's then finding your average and then outputting it. We can do the make. And there you go. You can see all the numbers read in from the file individually from right here. And then you can see the overall average that was calculated. So you can go change those numbers and play around with it if you want. Question 6, you are supposed to open the file called input.txt and read and count the number of lines that are in the file and output the overall result. So there's a lot of different ways you could go about doing this, but one thing you have to be careful about is that when reading in lines, you don't know how many characters they could have put on a line. Maybe they typed like 10,000 characters on one line, so lines being separated by new lines. You don't know what people will do. So you could try to read it in by doing a get line up until they do a /n, but you don't know how many characters they could have actually typed. So for most times, if you picked a large number for a size for your buffer, or maybe the maximum size for an actual buffer, that's okay. But here when it's files, it could be one huge, really long individual line until they get the new. So it really wouldn't be a good idea to use the get line. It'd be better just to do it manually because we're being safe and just read in like characters individually until you hit the actual new line. And every time you hit a new line, okay, that means, okay, that was the marker of a line within the file, so increment our actual count. So I will comment out question 5, uncomment question 6, and save that. We can go down to the question 6 code, and it's the same that's in the actual solution. I've just changed it to actually use the test files like directory for the actual inputs. But otherwise, we are opening the file, making sure we can properly open it. Once we do that, read in one character using the .get method to read it character by character to not skip over any white spaces or anything else from right here. Then check if we've hit the end of file or not, and otherwise check, oh, is that character a new line? Then that counts as a line incremented. Otherwise, just keep reading characters and consuming them until we hit new lines, and then output it. So not the most efficient way. Maybe you can find a faster way. Here's just a basic way to kind of get this done. That's good for the start of 1633. So if I cat out test files, our input file right here, I just have it literally with line 1, line 2, all the way up to line 7. So we should get a count of 7 on this. Let's do another make. And there you go. Yeah, for question 6, we did get 7. So we're good. Whew. Going fast here, over 30 minutes. You can take longer on this if you need. Now, the next one is a trace, which you should do because you will most likely get this on the actual midterm or tests, or you've gotten it before, is doing a manual trace of what's going on in the actual code from right here. You can actually run it. So we could go here, go back to main, comment out question 6, uncomment question 7. Right here. And then go down to question 7. I've got the code here, and I've called it question 7 instead of the actual main, but otherwise everything else is the actual same. So here we know that we've got a function that's called f that takes 3 parameters. Very important thing to notice is the first one is passed by reference, whereas the other 2 are passed by value. And so the pass by reference means, okay, whatever variable is passed into that first one, it's going to be changing the value that's stored in it. Whereas whatever variables or data that's passed into the last 2, the values will be copied, so the original variables will not be updated. So you know that you've got A, B, and C here. It's got 10, nothing here, and then 30, and you're outputting them. We're calling this function and having stuff overwritten, so it's very important to know, oh look, here's A. Well, that's the first parameter right here, and that's a pass by reference. So when we go to F, right here, any changes that are made to X inside of this code will change A that was passed in. And so you can notice X is just changed right here. So this change right here will be good for X as a local variable right here, but it will also change what A is when we come back out. So when we come back out of this function, even though there's no A equals, is that after this, you're going to have the actual A as what's been updated by that reference variable. B will be whatever is actually returned by the actual function from right here. C is this third one here. C is equal sign. It was not passed in as third parameter is passed by a reference, just passed by value. So C will be unchanged at this time. At this call here, you'll see that first off that yes, there's A, then there's C, but this will be A times by 2. That it'll compute that before doing the call to anything. So this will be 10 times 2, so 20 is being passed in for value Z. So I'm not going to go through the rest of this. I suggest you go through the manual trace as a practice for it. Once you have it, you can validate it by, you can see the answers here and the actual output you could get. You can also add in your output statements right here. So if I go and compile and rerun this, you can see you've got this output. And so if you're not sure how to do the trace, or if you're doing something wrong when you do it manually, you can probably come here and put some output statements to see what's happened to each variable during each step of the actual execution. Now, last from right here is that it's not in the actual solution, but it's in the original write-up. So I'll bring that file up here. Is you have a question 8, which is just saying practicing using what's called the IO utility. So some code that's been written for you to make doing some inputting, output, and validating of the user input easier for you. And so you are supposed to copy the IO utility directory from subdirectory in INS that's in the assignments directory and bring it up, and you're supposed to then compile everything, and you're supposed to basically write a small driver program that makes a single call to the read string method. Now, you can go do and copy that code if you want. I've also copied it up here, so you can go copy, take a look at the codes there, but with this code here that's in the directory, I've included the ioutility.cpp and the ioutility.h from right here, and my make file compiles and brings everything in. So if we open up, I'm going to make this screen a little bit bigger here because this file has a wider columns. Emacs utility.h, we can see the helper methods in here. So this has got extensive documentation that explains what it expects for the inputs, what it outputs, what it returns, and then how they actually work. So you have something here that is a read int that you give it a prompt, so a message to give to the user, and then it will then return back what they actually enter. And the EOF that you're passing in as output is a boolean that will be set true if the user entered a control D, otherwise it'll be set to actually false. So you can detect if you care if they're doing extra special characters to end the inputs. So you have one here for reading a boolean that'll ask them for a yes, no, then give you back a true or false. And you actually have one that'll read in a string, which is really important, where you give it the prompt, you give it the buffer to put it into. You have the max length of the actual array that it can do, so the max number of characters it can enter from right here, and then you give the user the minimum length of a character they have to enter in that same EOF. And so what this basically does is it forces the user to enter a string that's no longer than max len, and it must be greater than the actual minimum length that you have here. So these will be used most likely in future assignments, and they're very useful ones, so you don't have to rewrite a whole bunch of this code. We can open up the .cpp to see the actual code for this. So there's a lot more into this about reading the proper inputs, validating everything properly, so you don't have to rewrite this continuously, because look at this, all this code for your read string. There's everything else, and so this properly validates that they've entered in everything here. So this last part is just your practice of how to actually use it. I have written a solution already. You can see this is question 8. You can go write yourself and pause right now, or you can go take a look at question 8. And so key thing for this is that one at the very top of whatever you're doing, again, this is for you're getting code from another directory. So I have included the ioutil.h header file. Right here. And so we make our buffer. We need to have a variable just for right now to pass in if we care about that end of file detector, that control D. And then we're doing a read string. So this will be the message that's displayed to them. This is where the string will be stored into. The maximum number of characters that can be here. So it'll read in 9 characters and then use the last space for the actual null marker. This is the minimum length string that they have to enter, and then this is just for internally if we have a variable that's passed by reference to check if we care about the EOF. And so here we're not worrying about the checking if they've entered something like the control D. And so here then it'll just output the string afterwards. So if we go and run this, we can see here I'm just going to put in some less than 3 characters. And it gives you a warning, so it's less than the minimum. I will then put in larger. This gives you an error saying it's expecting a certain amount. And there you go. It's right within the right range, so it did everything else and cleaned up the input and did everything nice for us. So here's a very easy way to prompt and read one string from a user to a specific length. Okay. Other than that, I hope you've had somewhat of an enjoyable time with this lab. A little bit of a long one going through here, even with me talking fast. Boom. But otherwise, as always, as I like to end these videos, I hope that you're doing good and that you're making sure to take time for yourself. Because we're at the start of the semester with this material, but we're already jumping fast and it goes faster after this. So make sure to take care of yourself and maybe take care of the people around you. And maybe by doing both, we can do little steps to make this world a better place by making sure that you're okay and the people and animals and whatever else around you are also doing good. Otherwise, I hope you have a great day.